Welcome students. I Professor Deepak Kosti welcome you for this lecture. In this lecture, we are going to see additional relational algebra operations. So in the previous lecture, we have already seen relational algebra operations, but these are not sufficient. So because of which some additional relational algebra operations are required. So let us start. The fundamental operations of relational algebra are sufficient to express any relational algebra query. However, if we restrict ourselves to just fundamental operations, then certain common queries are lengthy to express. That is why the additional relational algebra operations came into picture. We define additional operations that do not add any power to the algebra, but simplify common queries. So these additional relational algebra operations are just to simplify the queries, nothing else. In short, I can say it is just to minimize the length of the query, or it is just to understand that we can write query in the simpler form. So let us go to the next slide. We have these operations. First, the set intersection operation. Second, the natural join operation. Third, the division operation. And fourth, the assignment operation. So let us start one by one what these additional relational algebra operations are. First, the set intersection operation. Now, before I explain this slide, I'll make you clear this is the output of the query. Okay, so for time being, don't see the output. Let me explain the query first, then we will go to the output. The first additional relational algebra operation that we shall define is set intersection, denoted with such a symbol. Suppose that we wish to find all customers who have both a loan and an account. Using set intersection, we can write by customer name from borrower relation, set intersection by customer name from the depositor. So the result relation for this query appears in figure 3.20 like this. That means the customers who are borrower as well as depositor. Note that we can rewrite any relational algebra expression that uses set intersection by replacing the intersection operation with a pair of set difference operation as R intersection S is equal to R minus into bracket R minus S. I hope you understood this. This is one relation, this is another relation. From one relation, it is minus of common. Thus, set intersection is not fundamental operation and does not add any power to the relational algebra. It is simply more convenient to write R intersection S than to write R minus into bracket R minus S. So this seems difficult to write. So this is for simplified using set intersection. So this is the first slide we have seen. Let us go to the next. The next is natural join operation. Now you know sometimes some columns are missing. Some information is missing. It is often desirable to simplify certain queries that require Cartesian product. Usually, a query that involves a Cartesian product involves a selection operation on the result of the Cartesian product. Now, let us see the example. Consider the query. Find the names of all customers who have a loan at the bank along with the loan number and the loan amount. So the query is simple. What we want? Names of all customers who have loan at the bank along with loan number and the loan amount. So three columns are expected. So we first form the Cartesian product of the borrower and loan relation. because two different relations have two different informations. Once we have Cartesian product, then we select those tuples that pertain only to the same loan number, followed by the projection. The resulting customer name, loan number, and amount. So the query for that is by customer name, loan number, and amount. So this match is required. This is what the projection. Borrower.loan number equal to loan.loan number. It must be there. Then and then only we will get the names of all customers who have a loan at the bank and along with loan number and the loan amount. So this is what required for Cartesian product. So borrower into loan is nothing but this is Cartesian product. On this Cartesian product, this query is applied. So this is called as natural join operation. I hope you understood. Let us go to the next. Next is the division operation. Now division operation is required when we have a word or a phrase for all. Now suppose that we wish to find all the customers who have an account at all the branches located in Brooklyn. So for all, here is the phrase for all. So we can obtain all such branches in Brooklyn by the expression relation 1 is renamed. Relation 1 is new name. R1 pi branch name projection where branch city is equal to Brooklyn on relation branch. So all the names of the branch whose city is Brooklyn will be displayed and that relation will be named as R1. So this is called as the division operation. Let us go to the next part, last part, that is the assignment operation. Now sometimes we need to assign values or sometimes we need to assign values to a particular thing. Then assignment operation comes into picture. So it is convenient at the time to write relational algebra expression by assigning part of it to temporary relation variables. The assignment operation denoted by arrow works like assignment in programming language. So it is same as programming language, but instead of assignment statement equal to, here arrow is used. The evaluation of assignment does not result in any relation being displayed to the user. Rather, the result of expression to the right of arrow is assigned to the relation variable on the left side. So this relation variable may be used in subsequent expressions. I hope you understood the assignment operation. Simple, just like assignment statement in C language. Conclusion. Thus we have seen additional relational algebra operations. Now next part we are going to see that will be a little complicated. For time being, watch the video again to understand the concept. Slide credit goes to book Database System Concepts, 4th edition. Happy learning. Do subscribe the channel to get the notifications of new videos. Thank you.